Everyone, welcome to Dr. Ravi's Academy. In today's lecture, you will be learning how to draw the shear force diagram and bending moment diagram for a given simply supported beam. Let us look at the beam. A beam of length 8 meters length, it is subjected to 3-point loads, 8 kilonewtons, 4 kilonewtons and 10 kilonewtons at various distances. Now, you are going to draw the SFD and BMD for this particular given problem. So this problem you can solve exactly in 3 steps. The very first step of the problem is you have to find out the support reactions at A and B. For that you have to consider equilibrium of the beam and write the equations of equilibrium and write the first step. Let me call step number 1 is determining support reactions. Let me call it as support reactions at A and B. For this, let us write sigma MA is equals to 0. That is sum of the moments about left end A. I am taking a notation that anti-clockwise turning moments are positive. So with this notation, I am writing the equation of equilibrium, that is moment sum about A. Let us see that 8 kilonewtons, 4 kilonewtons and 10 kilonewtons contributes clockwise turning effect, and let me write it clockwise is minus. So this equation is minus 8 into 2 minus 4 into 2 plus 3 5, the moment arm is 5, and minus 10 into the moment arm is 2 plus 3 5 plus 1, that is 6. This is what exactly the contributing clockwise moments, and RB, the other end support reaction, is contributing anti-clockwise, that is plus RB into length of the beam is 8 meters is equals to 0. So this is the moment equation, and rewrite this. I am interested in RB, so RB, that is 8 times it is RB is equals to 8 2s are 16, the other side it becomes plus 4 5s are 20 and 10 6 it is 60. So the total becomes it is 80 plus 96. It is 96 divided by 8 is your RB, and it is 8 1s and 2s, it is 12 kilonewtons. The RB value you have calculated, it is 12 kilonewtons. This value is 12 kilonewtons. And if you write sigma Fy, sum of the forces along the y direction is equals to 0, and it gives you that it is RA plus RB. These two are pointing upwards, positive, and the other side it becomes negative. That is 8 plus 4, it is 12, 12 plus 10, 22. So it becomes 22. So you are interested in RA, so your RA is equals to 22 minus RB. RB you got it is 12, and this value is 10 kilonewtons. Your RA is 10 kilonewtons. So this is very first step of the problem, determining the support reactions for a simply supported beam as well as overhanging beam. So this becomes your first step. Now the subsequent step is proceed for the SFD, shear force diagram. So that is for SFD. Let me write SFD, and before writing the equations, let me select the sections. I am calling this as 1 1 at a distance x1 from the left hand, and in this I am selecting another section, that is x2, that is also from left. Let me select section 3 3, it is from the right, this is x3, and lastly here 4 4, it is at a distance x4 from the right hand. I have taken x1 and x2 from left hand, x3 and x4 from the right hand. So let us write the equations, shear force equations for these 4 sections. Let me call, as you know that a standard symbol for the shear force is V. It is, let me write it is Vx1 is equals to, as you know about this particular section, 10 kilonewtons is contributing clockwise turning effect. Clockwise turning effect is always positive shear force. So it is a plus 10, and here this particular 10 kilonewtons is valid from beginning, that is at point A to point load 8 kilonewtons. It is valid for, so that means it is x1 is equals to 0 to, it is valid up to 2 meters. So this is my first shear force equation, and let me write Vx2 is equals to, that is section 2. Here this is my section, let me call it is 2 2, and this particular section, your 10 kilonewtons is contributing clockwise turning effect, that becomes your plus, and 8 kilonewtons anti-clockwise, that is minus 8, and it becomes 2. And this is valid, your x2 value from 2 to 2 plus 3 5, it is 2 to, it is 5 meters, 2 to 5 meters, it's valid. That is your second equation. And Vx3 is equals to, let us see, 3 is, it is from the right, and you have 12 kilonewton support reaction contributing anti-clockwise turning effect, and that is minus 12, and this is valid. X3 is equals to, that is 0 to, it is valid up to 2 meters length, that is 0 to 2. And lastly, Vx4 is equals to, so this is the section, and about this particular section, your 12 kilonewtons is contributing anti-clockwise, that is minus 12, and let us see 10 kilonewtons about this section contributing clockwise turning effect, which is positive. So you have minus 2, and this is valid. X4 is equals to, it is 2 to 2 plus 1 3, it is 2 to, it is 3. So with these various values, you can draw the shear force diagram. Let us look at this. It 0 to, here x value 0 to 2, you have plus 10. So let me take a height of 10 meters, and it is, I am taking this as my neutral axis. Here it is 10 meters. This value is 0 to 2, and it is, the value is 10. It is plus 10, and see that it is 2 to 5, that is next it is plus 2, and this value is plus 2, and x3 0 to 2, that is the other side, it is again 12, this is minus 12, and lastly it is 2 to 3, it is minus 2. So this is minus 2. These are the various values of the shear forces represented along the length of the beam. So let us give hatching and denote the values properly. So this is your SFD, shear force diagram. Now let us proceed to write bending moment equation. That is for bending moment diagram, let us take the same sections. You can write down mx1 is equals to, as you know that it's very important to understand this bending moment. You know very well that it is a sagging moment. If a moment contributes smile effect, let me call this as smile effect as for your WhatsApp symbol, you can call it as plus, and sad effect is minus. So with this notation we'll be writing the bending moment equation, and let us write first of all first equation. Here 10 kilonewtons is contributes smile effect, and it is plus, that is 10 into your x1, and it is when x1 is 0, your mx1 is also 0, and when x1 is equals to, this is valid up to 2, x1 is equals to 2, your mx1 is it is 10 into 2, it becomes 20. Now let us write the equation for the mx2, that is section 2 2. Here 10 kilonewtons contributes smile effect, and 8 kilonewtons contributes a sad effect. So it is 10 into x2, let me call it as plus 10 into x2 minus 8 into, it is this momentum x2 minus, it is 2. It is x2 minus 2. This is the equation. And let us look at this. When x2 is equals to, x2 value is, it's valid between it is 2 to 5. When it is 2, your mx2 value becomes, it is, if you substitute 2, so this becomes 0, and it is 20. So it's a checkpoint. You can check that it is mx1 is 20 and this is also 20. And when you substitute x2 is equals to the other end, it is 5, and your mx2 value, you can see that it is, if you substitute 5, it is 50. So this value is 50, that is a 10 into 5, and here 5 means it is a minus 8 into, it is 5 minus 2, that is 3, 3 8s are 24, it is 24. So this value is 26. You got it is 26. And mx3, let us look at that mx3 value. Write the expression for the mx3. Let us see that 10 kilonewtons is contributing again smile effect. You can write down it is a plus 12 into x3. When x3 is equals to 0, that is right hand, it is your value is mx3 is 0, and when x3 is this value goes up to 2 meters, you can see that it is 2, then your mx3 will be, it is 12 into 2, that is 24. And lastly, the last section, that is 4, it is mx4 is equals to, you can see that it is 12 kilonewton, it contributes a smile effect, that is 12 into x4, and see that 10 kilonewtons contributes a sad effect, it is a minus 10 into the momentum is x4 minus 2, x4 minus 2, this is the equation. And when you substitute x4 is equals to, your value is x4 is valid between the 2, if you substitute 2 value and this becomes 0 and you have 24, your mx4 is beginning value is 24. And when you substitute x4 is equals to, it is valid up to 2 plus 1, that is 3, and your mx4 value will be, if you substitute 3, so 12 3s are 36, it is 36 minus, here 3 minus 2, it is 1, 1 into 10, that is 10, you have a 26 value. Now with all these values, let us draw a neutral axis well below the shear force diagram. Let us ensure that it is alignment and the salient points. So your beginning value here, when x is equals to 0, your this value also 0, and when x is equals to 2 meters, it is 20, you have this value is 20 plus 20, and when x value is 20 and the next value it becomes 26, it is somewhere here it is 26, and this, see that the other value is 24, little below this it is 24, and lastly the other end is 0. Join all these with straight lines, and this is what exactly your required bending moment diagram for the simply supported beam. Thank you.